So now we are going to implement all the operation of queue by using the array. There are two ways we can able to implement the queue. First one is the by help of the array, that is the static memory location. Second one is the linked list implementation, which is dynamic memory allocation. So in this video, we are just going to cover how to implement the queue by using the array. So before going to details, we have to know what are the operation is performed on the queue. So first one is the enqueue. Enqueue is the operation where we are going to add or element or insert an element from the rear end, and deletion is the dequeue. Dequeue is the deleting an element from the front end. All the details of the queue operation I have already discussed in my previous video. I will put in the description section. You can go to the previous video and just learn what are the details of the queue. Then whenever we go for implementation, it will be easy. So dequeue is the process where we are delete an element from the queue, and the end we are using is called as the front end queue. Next operation is the pick. Pick means it is going to return which element is present inside the front pointer. So there are two pointer of the queue. First one is the front where we are performing deletion. Second one the rear where we are going to delete the item. Queue overflow. Whenever we go for the array implementation, at that time what happened? We initialize the size first. Then we are going to insert the data. So if we initialize 5 element and after that we want to insert, there is no space. Such type of situation we call as the overflow. So whenever we go for, we have to check whether the overflow happened or not. Last operation is the underflow. Underflow means when there is no data present inside the queue, at that time we called as it is a, as we know, queue is a collection of element where insertion is done from one end and deletion is done from another. For example, we are performing insertion. So this end we called as the rear or tail, and deletion is done from another end. That is called as the front end, or we called as the head. So from head we are. So the element insert is going to be delete first. For example, in this case, initialization means there is no element. So what happened? Initialization, if you go for array implementation, here this is the array, we are going to store all the element. 0, 1, 2, 3, 4, 5, 6, so on. So here the first element is going to be stored. So after that, what happened? If I store one value, then only the pointer, the front pointer point to this one, and this first element is the going to be delete first. So this is the rear as well as the front. Before that means right now there is no element. So this is the value is -1. As the front end is used to delete an element, so we have to make a condition that if front equal to -1 initialization. Anyhow, whenever we go for the implementation of the queue by help of the array, both the front pointer as well as rear pointer. Rear pointer points to the element, the side where we are going to insert. So this is the position we are inserting. From here we are deleting the element. So initialization means whenever there is no element, at that time what happened? Front points to -1, rear also points to the first one. So we have to check if the front value is equal to -1 or greater than, or it is greater than. Why it is greater than? First condition we are understand. For example, I store the value. Let us understand there are some values already present inside the queue. So for example, 10 is present, 20 is present, 30 is present. So this is the front end. This is the rear. So this is the position where we are going to delete the item. So this is front, this is rear. So what is the front value? Front value is 0. Rear value is 2 because it points to the index. So rear value is 2, front value is 0. For example, we go for delete operation. So delete operation means this value is deleted. Once the value is deleted, then what happened? the value is deleted. Means now front point to this one. For example, we have deleted this value right now. So once we delete the value, then what happened? Whenever we delete this one, second value we are deleted, then what happened? Front point to this one, third value, that is the 30. Again, we are delete this value. So once we delete this value, then what happened? Whenever we are performing deletion, at that time, what happened? We are increment the front end. Right now, front is 3, rear is 2. This is the condition you have to understand thoroughly. Right now, the front value is 3. What is the front value? Front value is 3. Rear value is 2. It means that there is no element. Is there any element? No, there is no element because already rear points to the position where we are going to insert the value. After that, we are not insert any value or we are not perform any enqueue operation, but we are already delete the value. So right now the condition is that is the empty. If I want to delete any value, it cannot possible. That's why here the check condition, if the front value is equal to -1, that is the initialization, or greater than the real value. Why we go for greater than? Reason is that data is already present. After that, we are deleting the data and we are not insert any data. At that situation, we call it is a empty condition, means there is no value. So for that, we have to check. So what condition you have to write down? If front is equal to -1 or front is greater than rear. So in this case, what happened? We have to return 1. 1 means it is true. Else we have to return 0. So if front equal to -1 or front equal greater than the rear value, then only the our queue is empty. Otherwise, it is has some value. So this is the condition for the next condition is our next operation we have to perform, that is the each full. Each full means we want to check whether our queue is full or not. So when we have to check, so for example, this is our queue. Elements are stored inside the queue. So this is our front to delete element. This is for rear to insert the value. Check if rear value is equal or greater than the maximum size of queue, then the return true, otherwise return false. Is full means we are going to insert the data. So insert the data means we want to check whether any space is there. So if rear is greater than equal to, if the rear is here, after that it cannot able to insert the value. That's why it is greater than equal to maximum size. For example, I did 1, 2, 3, 4, 5, 6. So what is the maximum size? It is 6. It is greater than equal to, then we cannot able to allow insert the data. If we are not able to insert the data means there is no space present inside the array to insert the value. So that's why it is greater than equal to. And whenever we are going to write down the code, at that time we are not using the 6, we have to use the 5 because indexing starting from 0 to n minus 1. So max size -1. So what we have to write down, if rear is greater than equal to max size -1, then return true. True means 1. Else return 0. So this is the condition for the each full condition. Next operation of the queue is enqueue. So what is the enqueue? Insert an element into the queue. So here first we have to check whether queue is full or not. If the queue is full, then we have to generate, that is the condition. That condition we called as the overflow condition. So we make it this overflow and we have to exit because we cannot able to insert the data. If the queue is not full, means there is a space, then what happened? We have to increment the rear pointer. Why rear pointer? Rear pointer is used to insert an element into the queue. So we have to point to the next empty space. After incrementing, we have to insert element into the queue. So this is the way we have to perform the operation. So For example, this is our queue. So this is the index because we are implementing by using the array. So initialization, that is the front equal to -1, rear equal to -1. So whenever we are going to insert any value, so first we have to check where is queue is full or not. If it is full, we have to make the overflow message. Overflow message and we have to exit. So what is the overflow? If there is no space, so what is the condition? Because this end we are using to insert element and this end we are going to delete the element. So this is our front end, this is our rear. So if the rear already points to the maximum size, then what happened? We cannot able to insert. Reason is that there is no space. So maximum size means overflow. That is the condition we are already exist. We have to check if is full equal to true. If it is true, then what happened? We have to print overflow. Else means if the queue is not repeated. For example, this condition. Right now, this is the rear point to this node. Sadidar index 2. Then what happened? Increment the rear pointer to the next empty. So next empty places, for example, 1, 2, 3 data is already. So for next we have to point to the next index, that is the rear point to the next empty space in the queue. The space should be present. Once it present, insert the element into the queue location. For example, I want to insert 4. So then I have to insert the 4 into the queue location where the rear point is. The rear pointing to this location, so we have to point to this location. So this is the way we can able to perform insert an element into the queue, and whenever we go for a queue, it is called as the enqueue. Enqueue means enter an element into the queue. That's why it is called as the enqueue. Next operation is the dequeue. Dequeue means deleting an element from the queue. It is called as the dequeue. So whenever we are going to delete, first we have to check whether any element present inside the queue or not. If the element is present, then only we can able to delete. Otherwise, we cannot able to delete. So if the queue is not empty, access the data where the front is pointing, because front end we are using to delete an element, increment the front pointer to the next available data. So this is the way we can able to perform the deletion. So first we have to check whether data is present or not. So for example, this is the so right now there is no element is present. No element is present means front point to this one, rear also point to this location, that is the -1. So you have to check if the queue is empty. Yes, it is empty. Then we have to print underflow and we cannot able to print 11. And we have to exit. Then we are insert some value. For example, I insert the value 10. So what happened? Front point to this one, rear also point to this one. Again, I insert a value. So now rear point to, after insertion, what happened? Rear point to the next node. Again, I insert a value 30. Once I inserted the value, then what happened? Rear point to the third value. This is the way the pointer is incremented or data pointer is incremented. Now rear point to 2, front point to 1. If the queue is not empty, for example, right now the access the data where the front is pointing. So front right now point to this one. So you have to access the data means we have to access this one. Then means we have to access and we have to print out that the 10 is going to be deleted. Then front is incremented by 1. So right now front point to 0 index. Then what happened? Front to the next. Next means, so now this is front means now our queue is consist of only 2 elements. Next operation we have to perform, that is the peak. Peak means it is retrieve only the value which is point to the front end. Then what happened here also we have to check whether our queue is empty or not. If queue is empty, we cannot able to retrieve any value. Otherwise, we have to retrieve the topmost element from the queue. So here what happened, for example, is our queue. So now this is front end, this is back or rear. Rear also we called as the back also or tail of the queue. So now it will be pick which value. Retrieve the data at front pointer. There are two pointer, front pointer, rear pointer. So whenever we want to go for the pick value or retrieve the data, it will be retrieve the 10 value and it will be displayed that 10 is stuck. So whenever we go for it will be displayed that is 10 is the top element present inside the queue going to be delete first. Then it will not remove the value. Only it will retrieve the data about the front end but without deleting this one. Just write down the code how to implement the queue by using the array. So first what happened, we have to create a file. For example, we create a source file that is. So first we have to write down his include. Then here we need the one array to implement the queue operation. So for example, I declare array size is 100. But anyhow, user has to give the maximum size. So for that we make a max size. Then another one, we make the front equal to -1 initialization, then integer, rear also -1. So initialization to value, then we have to write down the function for isempty. This is our algorithm. Check if the front value is equal to -1 or greater than the rear value, then return true. Otherwise, return false. Return true means we are going to implement return true means it is 1. Otherwise, it returns 0. So as the function return integer value, we have to write down integer. Then the function is empty. First condition, if the value is front. So if front is equal to -1 or front is greater than rear, then it returns value 1, else so this is our is empty function. We have to write down that is empty. Is empty is over. Now we have to write down the is full. So what is the algorithm? Algorithm here, check if the real value is equal to or greater than the maximum size of queue, then return true. Here also return value is integer value. So we have to write down each full, then the name of the function, then return value. So if here is greater than equal to max size, here max size -1. Reason is that we are going to implement the array. So indexing starting from 0 to n -1. That's why maximum size -1. Then it return 1, else and 0. So this is our each full condition. So if value is real maximum size, then it returns true, otherwise it returns false. So next function is we have to go for integer pick. So this is our enqueue algorithm. Enqueue means insert an element into the queue. You have to write down in the code. So check if the queue is full. If the queue is full, generate the overflow. Full means each full function returns the value is true. Right now we just complete each full. So here what happened? So for example, the function does not take any parameter, does not return also any value. So this is what. So here we have to check if. So our queue is full, so insertion operation or enqueue operation cannot perform. So this is the thing. So you have to write down whenever our queue full is true. So if it is true, else means space. Inside our space is there. If the space is there, if the queue is not full, increment the rear pointer to the next empty space. So here your plus plus, then insert the element. So here we have to what to do? We have to insert the element. So our array is which name we are declare. We have to check whether we declare the array. Yes, we are already declared the array. Array name is A. So here A rear stored which value? The num, for example, num the we were entering the value is num and we store the value. But in this program, till now we are not write down the num. So num is an integer, so we have to declare the data type integer num. Then here before entering, we have to just write down printf, enter the element into queue. Once we write down, after that we have to scanf. So this is the things we have to do for the enqueue operation. Means first we have to void. Here we are not write down the enqueue function name. So enqueue function name is the enqueue integer num. Then is full. We have to check overflow enqueue operation. Else printf, enter the element into the queue. Whatever element we enter, we store inside the num. Then rear plus plus. Then we store the value inside the queue. After that, you can write down the insertion or enqueue operation successfully. If you want, you can write it. It is your choice. Printf. Here also you can write down enqueue successful or enqueue done. It is your choice. Whatever you want, you can write down. Means after insertion, output will be displayed. Insertion is enqueue done. It is your choice. Depend upon our programming style, we can do it. Next function is that is the dequeue, means deleting an element from the queue. So this is our algorithm. Right now we have to write down in the code. So in this program, we are just doing in such a way that the function does not take any parameter, does not return value. So we have to write down void dequeue. The function does not take any parameter, does not return. So what is the first statement? Check the queue is empty or not. If the queue is empty, generate the underflow error. So queue is empty means we are already write down a function that is empty. So we have to call the isempty function. If the function is true means what? Our queue is empty. If our queue is empty, what we have to write down? We have to generate underflow error and exit. So we have to write down printf queue is underflow condition deletion can possible. We can write down under flow condition, that's why deletion cannot possible. Else means elements are present. If the elements are present, then what we have to do? Access the data from front end is pointing. Access the data means whatever data inside the front, we have to access. For example, we print this value. This value is going to be delete. We can go for %d, or we can write down the deleted data is %. It is our choice how we want. Then which value? That is the Q front. Q we represent by RA, name is A. So A front. So it will print this value. Then increment the front pointer, because once the element is deleted, we have to increment it. So how to increment? Front plus plus. Then we can delete this. So after that, what happened? Deletion is over. Or you can write, no, or we can go for next line. So this is our else part. So this is all about our dequeue operation. So we are already completed the enqueue, is full, is empty. Only one is remaining, that is the pick. So next to write down, that is the pick function. We have to write down the pick function. So what is the purpose of the pick function? Pick function is used to retrieve the element from the front end. So whenever we are going to retrieve, at that time we have to check. Algorithm is written, check if the queue is empty. If the queue is empty, generate the underflow. So here also I make the function as a void, means the function does not take any parameter, does not return any value. So here first we have to check if is empty. If it is empty, then what we have to do? We have to write down queue is empty, printf. Else means data is present. If the data is present, what we have to print? Top element. So printf. Here we are not going to delete anywhere. We are only retrieve the information. So %d is %d is the it value. Which value? That is the RA front. So now we are already completed all the function. Right now we have to write down the menu drive program. So in this program, we are already completed the isempty, isfull, enqueue, dequeue, and pick. All the function we are already write down. So right now we have to write down integer main function we have to write down. So here, so for example, we are going to choose a case which one we want to enqueue, dequeue, or pick. So for that integer in choice I write down, then printf new line. This is for only output format. We are writing then printf new line. One option is for enqueue, then two for dequeue, then three for pick, pick, then four for display. Now we are not completed the display part also. Fifth one is for exit. So this is the way we can write down the menu drive program. Whatever we enter, we go for scanf. percent D. So this thing means from 1 to this, we have to write down in a do while loop, so that all the things should be done in a multiple way. So this is our do. For example, this is our end of, then while choice is not equal to, choice is greater than, not equal to 5, or greater than equal to 5, or not equal to 5 also we can do. It is up to us. Sometimes we have to go according to that. Now once we enter the choice, then what happened? We have to put switch case. Now we have to write down switch case, switch value, switch case. Now we have to write down which value? Choice value. We have to put the choice value. After that, if it is a case 1, then we have to go for our enqueue function. Better to copy the function so that no problems occur for the spelling mistake or anything. Is to dequeue. P is for pick value. Case 3, pick function. Then case 4, display. We are not write down display till now. Break. Then case 5, this is for exit. So we have to write down printf break. Otherwise, default case is that invalid options. So till now we are not completed, have not done the display function. So we have to write down the display function. Void. So whenever we go for display, we have to check whether data is present or not. If the data is present, then only we can able to print. So if is empty, if it is true means there is no data to print. So we can write down printf empty. Else. So in else what happened? We have to print from front to rear. So here what happened? We required a for loop for I equal to front, I is greater than equal to rear, then I plus plus. We have to do it. So whenever we print the value, at that time we want it should be a one line format. That's why we make each and every element should be gap is that is one tab. So we write down printf percent d after the one tab. And which value we are going to print? That is the array and I value. It is going to print I value. Okay. So before that, we have to initialize the I value. So integer initialize or declaration. Here we will declare because we are going for initialization with the front value. Else here what happened? We have to write down printf q elements are. It is our choice how we want to write down our output. So it will display only q elements are. Then new line will be created. Then this is our main function. Okay. So let us compile it. Before that, we have to save the file. Till now, we are not save our file. So always whenever you open, it is better recommended you save the file. I have done great mistake till now. I have not saved the file. So printf. Okay, okay. Double. Okay. I equal to I plus plus. What is the error? Okay, here the statement should be ended with the semicolon. Okay. Display. Here also the function name should be display. Semicolon. Now there is no error. Let us run the program. Here 1, 2, 3, 4, it's not looking good, but anyway, we have to change the format. For example, 1, queue is overflow. Immediately it's showing the queue is overflow. Why? Can you tell me why we are getting this error? 4, here new line is not there. Okay. Can you tell me why immediately we are getting the overflow? What is the condition for overflow? Here what happened? We make the array size equal to 100. So, and we make the max size. Here what happened? If overflow means what? Rear is greater than equal to max size minus 1. But here we are not store any value. What we assume that whenever we are writing the program, so at the main function we have to ask the end user to enter the value of maximum size. But here in main function we are not mention that. So if we are not mentioned, then what happened? It takes the garbage value and we are getting the error message. So in this program, I just try to do all the possibilities what you are going to do whenever you are doing the program. And you are thinking, no, no, ma'am did all the program execution is done, but whenever we are trying, we are not getting the correct answer. No, no. For each and every program, you have to check what is the logical error, what is the compilation error, and you have to rectify. Here what happened immediately we got the overflow. Reason is that we are not initialize the value of max size. So we have to ask the end user enter the size of queue. Whatever it will be, we have to scan it. So this is max size. This is also max size. Same thing. Let us once again we compile and run. Okay. Later the enter size. Enter size, for example, 5. After that, the program is terminated. Now we have to think that after entering the 5 size, why immediately? So here max size, then do while. What happened? Here what happened? We write down the max size, but there is no ampersand symbol. This type of mistake you maximum people are doing and telling that no, we are not able to get the correct answer. No. So compile and run. Okay. Let us enter the size 5 right now. Yes, we are getting, but still one space is there. That's why 1, 2, 3, 4 is not in a one line. So we can enter. After that, I enter 1, then enter the data 1, 0. Enqueue is done. After that, it will stop. That is the enqueue done. Insertion is done. But what happened? It should be go to the first location or not. So once the is done, do while, then it will be go to the, again it should ask as per our assumption, but here we are not getting as per our assumption. Can you tell me why? Reason is that the it's execute only for once, but it will not go for second time. So this is the problem whenever we are performing the do while. The same mistake maximum time we are doing. So what is our while condition? While condition is greater than, but exit from the program is that is our 5. So here we have to write down not equal to 5. Let us check this program once again. Yes, right now it's going coming to the second. But whenever I enter 1, stack is overflow. Enqueue operation cannot perform. So this is the case whenever we are doing any program. This is the common problem. So we have to check once again where we did the mistake. So after exit, it will be immediately to asking. So we have to go for this one. After exit, it should be one new line. So output will be good to explode. Enter the size. Size is 5. Now 1. Enter the value 1. Then enqueue 22, 1, 33. So last program we enter only one size. So we got the error message. So right now rib element is already insert. So let's display. Queue is empty. But whenever we go for display, it's showing that queue is empty. Let's go for the 2. Queue is underflow means we okay. Peak is underflow. It means that we are inserting the element, but it is not going to the queue. So why? Because there must be something wrong in our enqueue function. So what is the enqueue function? Here, just see. Whenever we are entering the value, we are just make the rear to increment, but the front value is initialization what? -1. So here also we make the front equal to -1. But whenever we are enter value, we are only change the value that is the rear equal to plus plus. But whenever only first element we are inserting at that time, we have to make the front equal to 0 or not. Initialization that should be done because initialization is -1. So first element we are inserting at that time, we have to make the front value equal to 0. That's why we got the error message, but we are entering, but the front value is not changed. So then what happened? It's storing the rear value only. But front pointer -1, it does not incremented. So we have to check here. Whenever we are entering the value, we have to check if front equal to -1, then what we have to do? We have to make the front equal to 0. That initialization we should do for first element. Otherwise, all the codes are correct. I think so. Let's see. We have to run the program and find out. So first we enter. What is the size is? 1 means immediately invalid option. So I enter 1. enqueue is done. So first element we are done. For example, I want to insert. Queue is overflow. Why? Because I enter the queue size is 1. That's why we are good. So let us execute once again. 5 element enqueue 1 1 1 2 2. Second element. Third element we insert. Let us go for display. Queue elements are nothing is going to display. Again, we are facing the error message. Let's go back to the program displays. So right now it does not show the underflow. Previous we got the error message that is the underflow. Right now few elements are this. So here what happened? I equal to 0, I greater than. Here percent d a of I. But what happened? Nothing is output. Why? So here what happened? We make the font I equal to 0. I greater than rear. If it will greater than rear means rear is the end position. I'm inserting the last position. So after that, there is no value. So instead of writing greater than, what we have to write down? Less than. So these are the silly mistake we are always did. So you have to cross verify. Let us check once again 5 element 1. Enter the value 1. Then 2 2. For again 2 2. For example, right now we go for display. So right now we display 11 and 22. 11 is the first element, second is the 22. For example, I go for pick. So it will display 11. 11 is first. If I go for pop operation, dequeue. Dequeue. Pop is for the start. Dequeue for the queue. So first element inserted 11 is going to be deleted first. Second element deleted. Now queue is empty. So this is the underflow condition. So hope you are able to understand all the concept. For example, once again I execute the program. Enter the element 1. So second we want to enter 22, then 33, then 44, then 55. Already it is overflow. So whenever we try to enter 44, at that time we got the overflow. So we are getting the overflow condition. Then we go for remove the element underflow also we are getting. Then also if I go for the display right now, queue is empty. If I go for pick also, it is underflow, nothing to be picked. There is no element. So if I go for 5, so exit from the program. So right now our program is executed completely. So whenever we write the program, now there is a chances we are thinking something and we are writing something. And whenever we compile that time, at that time there is a some compilation or error or some logical error. So you don't have to worry about. You have to just go to the details of the program where we did the mistake. And I am 100% sure that you can able to complete your program. Got the result. So this is our complete program. Let us understand the time complexity. So time complexity is for the queue operation. For enqueue means we are going to insert a value. Insert a value means what are the statement we have to execute. So for enqueue, this is the statement. So for this statement means front or caldera. So this is a 4 5 lines. So you have to perform the operation. So this is for each and every time is a constant fixed time. That's why the time complexity for enqueue is 1. For dequeue. So for dequeue, what are the things we have to do? We have to just perform this operation. So it is also a constant time. That's why it is order of 1. For each empty also, you have to just retrieve and print. So if you have to retrieve and print means this is the fixed value. So for that, for pick function, operation is a constant value. For enqueue also, order of 1. For dequeue also, order of 1. Thanks for watching the video. Hope you are able to learn something. So please subscribe the channel, like the channel and share more and more